Hello, thank you. Yep, so my name's Jay Arch, or Jonathan Arch, you can take your pick. And I work in the public cloud deployment engineering team now. We're part of the Public Cloud Center of Enablement for Barclays Bank. I'm going to talk to you today about how we are currently using Chef in the bank, some of the journeys we've been through, some of the problems that we have, and then how we've used Chef to kind of solve those problems, and also some of the automation we've wrapped around Chef product to help us automate various process and stages to make it easier for our Chef team, etc., and easier for our developers, obviously. So, who are we? So, I imagine most of you on the call will know who we are, but I'll go through it anyway. So, we're Barclays Bank, a pretty big company, one of the largest in the UK. We do have a global presence in the investment space as well. We've been around for about 325 years, which is a fair old chunk of time. Around 83,000 employees, over 40 odd countries. Again, numbers always changing. It's a big old company, so people are joining and leaving all the time. We think around 10,000 developers. Again, numbers changing all the time. People joining, we have new teams expanding, especially in the new cloud world that we're diving into. The numbers of developers we're pulling in is growing quite rapidly. Around 110,000 servers across around about 4,000 applications. Again, both those change on a daily basis. We're decommissioning quite a lot of applications. We're onboarding brand new ones into our on-prem private solution, cloud solutions, and also for AWS as well. Servers split roughly 60-40, 60% of them around Windows Server, and then the other 40% are Linux, Red Hat, AIX, that kind of stuff. We've got already around 500 apps deployed within the hybrid cloud. We have an on-prem container-based solution that we've got in place, in-house written tool. So we've already got some app teams well onto the journey. And we're working hard now to pull the others in. So ultimately what we do is we move, lend, send, and receive money, okay, in various different fashions, whether it be retail, banking, high street kind of services, or we obviously go into the whole investment bank, corporate bank, wealth areas as well. But what that ultimately translates into is developing software. That's ultimately what we are turning ourselves into, is a software technology company, because that's what drives everything now these days. You know, you don't go to the bank these days that often. You do it all on your mobile phone, or you do it all on a laptop or on a web page somewhere. So it's developing software, and we're realizing that that's the key component of our business and how we drive ourselves forward. But it's not necessarily something we're new to. We've been developing technology in various forms for a number of years now. So if you go right back to the year 1966, we were the first UK credit card. So the first company in the UK to pull the credit card in. We then became the world's first user or inventor, effectively, of the cash machine. We invented the ATM. Other things we've done, so enlisting first UK bank on the New York Stock Exchanges, first debit card. We then do a humongous jump from 87 to the year 2007. And that's where a big technology change happened across the whole world, and that was the invention of the smartphones. The iPhone came out, it became more prevalent for people to have access to everything in their hand, carrying it around in their pocket. So we started changing our methods now and going to different ways of developing our services. So we've got our contactless payment cards, Ping It app launches, where you can ping money to people based on their phone number. We've got various other tools like the Barclays mobile banking app, web banking as well, mobile check payments, etc., etc. So we've been developing technology for a number of years now. It's always been core to how Barclays operates, as we realize that technology is important to our business. So what's our problem? What problems do we face on a day-to-day basis? And hopefully you guys on the call will all relate to this in some form or another. So 110,000 servers, right? It takes a bit of managing. To manage those servers, you probably need a lot of people. And sometimes that's not necessarily sustainable to have that many people. So just to look after that many servers and maintain them is a massive ask. We've got OS deployments to do, so we've got to keep those up to date. And once they're in place and they're on the ground, they're working, we've then got to keep that build up to date. Agent rollouts, we've got agents that are doing various tasks, compliance, security, monitoring, login. They've all got to be maintained themselves individually. They have updates, they have patches, they have new versions. You have to maintain those across 110,000 servers. The good old vulnerability updates that we all now have to spend a lot of time on. Patches come out, and we've got to react very, very quickly to how we get that out to the estate, especially if they're critical patches. We've got a very, very short SLA, and to mobilize the business and other app teams to push that out to 110,000 servers is no easy task. Security setting updates. We have our own build security settings, but sometimes they change. We have new settings come in, procedures get updated. We then have to push hard and get those pushed out as well. Config drift, obviously. All this stuff means that as time goes on and these things change, servers drift out of compliance. We have to maintain a level of compliance across the entire estate, and we're audited and checked on that level of compliance. So we have to regularly update it and regularly keep on top of it, and we need help doing that on such a large estate. We also have ad hoc changes, so things that happen as a result of a major incident. We have problems with disks, we have problems with firmware, we have problems with drivers, and all these kind of things can also mean we have to push out some piece of software to a set number of machines as quickly as we can. So we need to have agility to be able to do that. We're heavily regulated. That means we need to report on this stuff as well. So we need to be able to get meaningful data on these machines back to be able to know what does need updating, what does need changing, what is currently in compliance and what is not in compliance. So it's a constant check for the levels that we're at that time. And then we have application teams as well. They're deploying their own code manually in most cases. They're manually copying stuff around and manually executing stuff. So we have application teams doing their own tasks as well. So we see ourselves a bit like an oil tanker. It takes us a long time to speed up, to slow down, to change direction. Every time we make a change, it takes a number of months or sometimes years for that change to filter all the way through the business. So it's difficult with such a large estate and so many different application teams and so many different business areas and so many different technology teams across the globe in different time zones. It's difficult to keep on top of all this stuff. So we ultimately use Chef to do quite a lot of that stuff, which is obviously why we're here. So we use Chef now. It's a global strategic configuration management tool set. So it's the tool set we use for all automated configuration management. Okay, we tell everyone from the platform teams up to the app teams that's the tool they need to be using. We configure all our OS builds. So for new provisions, the entire build is built using Chef. We have a base build, and on top of that, we layer all the different layers for security, for all the different agents, for our access now is all configured via Chef runs. So it's configured once, first time on the build, and then maintained on a regular schedule to ensure that that level is constant on that Chef server, on that endpoint, sorry. So build, agent, security updates. We have a monthly release cycle. So we have a build update we push out every single month to update with the latest agents, latest security settings, etc. And we always make sure that then we audit and check that every single month to make sure everyone's in compliance. Our middleware applications now, so things like Apache, Tomcat, JBoss, and a number of other ones that are solely deployed using Chef cookbooks. So the only way you can consume those products within the bank is by using the corresponding Chef cookbook. We can obviously version it, we can make sure it's the right version, we can scan for people using older versions, etc., all pulling that from the Chef server. Application teams now, so they're using it, some of them are using it to base build their servers, so they'll pull on their app binaries, some prereqs, and some app config. They might install some additional agents like the middleware applications themselves, just to baseline their application before they then take it onto a different stage using a different sort of more of a application orchestration tool such as TeamCity or Nolio or something like that. But we have some app teams that do their full deployment using Chef. So they deploy the whole thing top to bottom. Some of them have discoveries running, so they use data bags to check for new nodes that have been added to the application. So they're doing it end-to-end, managing it all via the Chef agent. So that's great. We've got all that stuff we now do, but there's a lot of things around the Chef product that we would require a Chef engineer to do. Because we have such a number of developers now that will be asking for these updates and these changes, we need some automation to wrap around it to make it easier for everybody. So we need some kind of way to allow our application guys to upload their chef changes, so their cookbooks, predominantly in this process, to the chef server. So we've got self-service front end, automated cookbook testing built into the pipeline. We have change management control in there as well. So we've got to have change management every time we make changes, so we can track who's made what change. And also the business have a chance to ensure that things go out to their services when they're able to do it, when they're not in business hours, that kind of stuff. Minimal resource from the chef team, obviously. We don't really want a load of chef guys just uploading cookbooks, because that just takes a lot of time, a lot of effort. We want to try and reduce that to make sure that we're utilising the team in the most efficient manner. So for this, we developed a pipeline that we call the Chef Cookbook Delivery Pipeline. And I'm going to run you through that now, give you a high-level view, and then we'll talk about how a developer would step through that process to get their cookbook to the chef server. So at a high level, we have a dev side to the pipeline. So it's a Jenkins-driven job, and we use Git, or internally to the bank product, we use a Bitbucket as our trigger mechanism. So developers will push code to their repo in Bitbucket, and that will trigger a Jenkins job. First thing it will do is the audit tests. So we'll do a load of automated testing. We'll talk about all that in a second. If the tests pass, and make sure everything's good, it will then upload the cookbook to the chef server at that version. And then the next thing we'll do is promote it into our dev environment. Okay, so there's no pre-checks, there's no authorization at this point. As long as the audit tests pass, the cookbook will get uploaded to the chef server in the dev environment, and any servers that are mapped to that dev environment can then deploy the cookbook at that version and start doing further testing. So we try and keep that as open as we can to allow the developers to get cracking and testing their applications. On the prod side, we have slightly different process. So similar process, the branches in Bitbucket, so a development branch and a production branch. And when they push to the production branch, we run the same audit tests again. Don't necessarily need that if the version's been through on dev, but we run it again just to be sure, to make sure that the code is good and clean. This time around, we have a cookbook review phase though. So we've had to mandate in there that we have a manual review process just to make sure that someone from the chef team ultimately, or from the platform team, has vetted the code and make sure that we're not breaking compliance, we're not going to cause the chef run to fail, we're not going to endlessly reboot the server in a loop or anything like that. Check for things like that in the code. First time around, they tend to do a full check, top to bottom, and the second time around, they just do a diff. It's much, much faster. And then once that's done, all we have to do then is promote that cookbook version to the prod environment on the chef server, and then that's then free for them to deploy to their prod servers. So a bit of a process in there. As part of the review process, by the way, we also have first time round, brand new cookbook, first version gone to prod. There's no change needed because it's not going to actually impact anything. Second time round, the pipeline will do a check against the chef server, and it will see if that version exists already environment. And if it does, it forces you to raise a change. It will scan the chef server, it will pull back all the nodes that have got any version of that cookbook running on their boxes, and it will give you a list of them inside your change and say all these host names are going to be impacted by this change. You need to make sure that they're all aware of it and they approve it. So service now will then pull in the approval groups for all their mapped services, and then they'll be good to go. So I'll walk you through now from a developer point of view. So the developers have to stage through this in the various different processes. And we try and make sure that as much of this is done at the developer's workstation before we get anywhere near any kind of dev environments. Okay, that's kind of the whole DevOps kind of method. Okay, get the developers fixing the bugs and the basic errors and the basic problems before we start getting to proper development testing. So the first thing you've got to do is create a repo. So that's a web front end. Again, it's a page. Basically what it does is it creates a Bitbucket repo for them with their name of their cookbook. And in the background, it creates a corresponding Jenkins job linked to their cookbook. Okay, so it's their own unique pipeline mapped to their own cookbook repo. We then have a chef generator. So the cookbook that we've created, and in there we've preloaded all the stuff that we need to make the pipeline work. So we have some custom tests in there, some custom test kitchen config, some basic templated out files for recipes and roles, etc., etc. So They then generate their cookbook from that locally on their machine, and then they push that up to their repo in Stash. I'll call it Stash, but it used to be called Stash. It's now called Bitbucket, just in case you get confused. So they push it up to their branch, and that branch is, by default, is always the master branch. Okay, and we try and with Git and Stash and Bitbucket and GitHub and all those things, you can obviously do your own branching strategies, and it's one of those subjects everyone's got an opinion on, and they all sometimes conflict. We kind of pushed out what we think is the one of the ways we want to use this, and because we're using 2 branches for releases, then we say the master branch is your top level branch. You create feature branches from that master branch, and when you're ready, you merge back into master, and from master you go to your release branches. So you'll see that in this pipeline. So at this point, we're at the master branch. We've got an empty cookbook generated from our code generator. We'll create a feature branch, start working on it, and then the developer will then locally on their machine using Chef DK, they'll have Chef DK installed, they might have some kind of IDE installed, we use Visual Studio Code, or some of them use IntelliJ or a bit more beefy programs, Atom, things like that. And they'll do all their magic, they'll develop their cookbooks, they'll write their recipes, and they'll do whatever they want this cookbook to do. When they're ready to start testing, the first thing they must do, and actually as they do the development process, what they must do constantly is run local tests. Okay, so we've got 4 test levels, 3 at this point. There's another one afterwards. So we have Chef Spec running, we have Food Critic, and we have RuboCop. Now we do have it on our list to update RuboCop to Cook style, but for the time being, it's running RuboCop. And what the developer will do is we try and advise them to run this as frequently as you possibly can. The more frequently you run this, the quicker you get the errors up, and then the less you have to deal with each time. As you add more code to your cookbook, the less errors you have to deal with at the end. So we're trying to say, don't run it right at the very end, because you'll have hundreds of errors and it will take you ages to get through it. Just run it. Every time you make a change to your code, run it. You're going to find errors all the time. So you're going to go round in this a loop over and over again, constantly throughout the cookbook development cycle. So they run these tests. Now these tests have got to go green before they go to the next phase. We always say, before we push to Bitbucket, make sure you run these tests and it's all nice and clean. And the only time we advise against that is if you're going to make a change by running these tests that could break your code. So sometimes you say, push it to Bitbucket first before running the tests. But on the whole, we tend to say, try and make sure you push clean code to Bitbucket, mainly because if you've got other people working on the same repo, pulling code from the branches, they don't want to be pulling back your broken, erroneous code. You do the courtesy of at least making sure your code is clean. So when they pull it, they don't have to worry about RuboCop errors or Food Critic errors. So push it back to your feature branch. At this point, then we run some integration tests. Now, I'll talk to you a bit about Test Kitchen in a second, but we run Test Kitchen a bit differently in Barclays due to restrictions on our workstations. So we have an environment for Test Kitchen. And the key point we've got here, this process, is that environment will pull from Bitbucket. It won't come from your local workstation. So you initiate the connection, you initiate the creation of your Test Kitchen images or Test Kitchen VMs from your local workstation, but it actually calls in another Jenkins job, which will initiate the build of the machines and pull the code directly from Bitbucket. So before we run that integration test, we have to make sure that we've updated our feature branch. And then when we run it, it will pull that code down to the VMs and execute them independently. So we've run some integration tests, we've done our local tests, and we're getting to a point now where we think, yeah, code's looking okay. I think we're getting ready to start pushing to dev. Now, and again, obviously if there's failures, you have to come back to your machine. For the guys in Barclays, we always say, just again, remember, if you make a change to that code, if it fails in Test Kitchen, you think, oh, I've made a mistake with my recipe or somewhere, you then have to then update it locally, rerun those local tests, so RuboCop, Food Critic, make sure they're all clean, push that back to your feature branch, and then run the kitchen test again to pull the newer version of the code from Bitbucket. So we're at a version. Standard version right out the box is 0.1.0. Obviously, if you've been working on a repo that someone's already done, that version will be different. But for this little run through, we'll say that that's our version number. Now, before we go any further, we always try and drill into, guys, you've got to merge your feature branch back to master. Master's your top level branch. You've got to keep that up to date. If I'm a new developer joining your team, I need to know where's my benchmark branch that I'm taking my code from. Because we do see quite often with some of these repos that the master branch ends up miles behind all the others. And you end up in a situation where is the most up-to-date code, good code that I can take my feature branch from. So we try and drill into that, keep master up to date, everyone merges to master, and all the release branches come from master, okay? So we've got a version, we've now merged our code to master branch. You can, if you want, tag it in stash as well. Some guys do tag and some guys don't. We just leave it up to the developer how they want to manage it. And then we create a new branch from master called development. Now it's all lowercase, and that, when we created the repo in the very first step, it was pre-configured to look for any commits to a branch called development. And if it sees a commit to the branch called development, that will then trigger our Jenkins job. And the first thing it will do, run our pipeline tests, our audit tests. These are exactly the same tests you've been running locally on your machine. So if you're a good developer and they've all gone green before you've pushed, that test should have no problems. We do see a lot of people at this point where it fails, and that's because they've not been running their tests locally on their machine. So it can be quite a frustrating thing when you start pushing down the pipeline and it fails because Rubicop's detected a white space at the end of the line, which is very frustrating. So we always say, look, run them locally, keep running them, run them before you push to Git, and these tests should run a lot cleaner, a lot smoother. Obviously, those tests fail, you come back, you have to make the change, you have to run them again locally, push to your feature branch, remerge into master, and then do a new commit or new pull request from master to development. And then it sees the commit to development branch, triggers the pipeline again, audit tests run, and hopefully, if you've caught all your errors and fixed them, this time it will then pass. And then there's a next phase where it does an upload to the chef server, and it promotes to our dev environment. And from that point, you can then do your proper development testing. Now, at this stage, I always do advise our guys, Test Kitchen is not for application testing. Okay, Test Kitchen is for testing your cookbook executes against an operating system. Okay, the tests you run before are all just local code checks, static checks, or in-memory checks. But Test Kitchen is the first time where your code has been executed against an actual operating system. So you'll see it clash with security settings and other stuff. It's not there to actually do a full application test. Okay, so it's at this point where they actually start doing their full application testing. And they might obviously find that they've made a mistake. They've got something wrong in their brief, a version clash, need to update it, need to do a patch or whatever it is. So invariably, they'll come back to their machine, they'll make the change again, they'll rerun their local tests again to make sure the local tests go green. They will then push that back to their feature branch to update the feature branch. You can, at that point, rerun integration tests just to make sure the code executes and it doesn't cause a chef client failure. And then merge your feature into the master branch. From that point, you then do a new pull request to development, and that will trigger Jenkins again, rerun the pipeline tests. But at this point, if you were to push that again at this stage, it would fail. It would fail because we need to bump our cookbook version. Once that cookbook hits the chef server, it will not accept another push at that version without some background admin magic. By default, it will reject it, saying, no, I can't take that version, I've already got it. So you have to bump your cookbook version, bump to .1, push through your branches again, redeploy a new pull request to development. Development will trigger the pipeline tests. It will rerun again, and hopefully it should pass because we've been through it 100 times now. And then once it's passed, we'll say, yep, version 0.1.1 is good. I will upload that to the chef server and promote that version into the dev environment. Okay, and then at that point, you can then carry on the dev servers with the new version, testing the new version against your dev servers. Now that bit, all this section here is where you'll spend most of your time developing. You'll go round and round this in numerous circles. And although it sounds a lot when I'm talking about it now, eventually the guys seem to become slicker and slicker and slicker, and all these merges take seconds or minutes at most. So it's quite a slick, quite a fast process. And at this point, we've not actually involved any chef engineers anywhere. So the chef support team have not been involved. This is all just the developer running from their workstation. So we've done some dev testing. We've tested our apps now. We think, yep, everything's working good. I'm good to go to prod, I think, okay? So we do the similar thing. We come from master branch. We create a new branch called production. The repo, again, was pre-configured to look for any commits to a production branch with that exact name, so it's got to be lowercase. And then when it sees that, it will then trigger Jenkins. This time it's a production pipeline that runs. It will run the cookbook audit tests again, and hopefully been through this 400 times now. We shouldn't need to make any change. It very rarely fails at this point because you've been through dev and dev has passed. Cookbook test should pass. It will then trigger a Barclays review process. So this is where it raises a Jira to our platform teams. So we have Unix and Windows platform teams. They will review your cookbook. So like I said before, first time round, they will review it top to bottom. Second time round, they will just do a diff on the code and see what's different. It's much, much quicker second time round. First time round into prod with this cookbook, there'll be no change raised. It'll just promote it straight to the prod side because it's not going to impact anything in the prod environment because the prod environment can't even see the cookbook. It's the first time the prod environment will see this cookbook. Second time round, though, it will check the prod environment and say, does this cookbook exist? If it does, then I'm going to raise a change. I'm going to do a scan against the environment to see if anyone's got anything inside this cookbook in their run list. And if they have a role or a recipe, if they have, or if they're wrapping it or that kind of stuff, you'll pull back a list of the host names and put those in the change record for us. Now, the reason why we do that is because if you're not pinning versions in your cookbook, as soon as that new version hits the Chef server, that node will download it to the server and execute it immediately, okay? So we have to make sure that we've captured that in our change record. That change happens inside a maintenance window. The node itself has had someone from the app team approve the change and say, yes, I'm happy for that to happen. So that's why it's key, and that's why it's in there. So we need the Jira to be closed by the platform team, and you need your change to be approved in its maintenance window. Now, as soon as it hits its maintenance window, as long as that Jira is approved, within about 10 minutes, Jenkins will then upload that or promote it to the prod environment. Okay, the cookbook already exists on the Chef server. We just promote the version into the prod environment, and then you're good to go to deploy to your prod servers. Okay, so it's quite a process. It sounds quite a lot. In our training sessions, this will take me 40 minutes to run through with everyone asking me questions. But when you start getting cracking, the first kind of section, the first 3 boxes, you're talking maybe 5 minutes. And then after that, you'll spend all your time in the boxes going all the way up to the dev testing. And you'll spend quite a lot of time in that. But pushing through the environments and pushing through the different branches, we're talking minutes for each stage. And as long as you're running your cookbook tests constantly as you change in your code, they shouldn't really cause too much of a problem. So I'm going to talk to you now about Food Critic, because I mentioned Food Critic in our testing. Now, Food Critic is a static code and analyzer. We use it as part of our cookbook audit tests. Now, out of the box, it's got a load of preset rules in it. So there's 122, I think. I mean, that's just what, it's about 4 weeks out of date, so that number might have gone up. When I checked this, it was 122. So these are just community rules that the Ruby community and the Chef community have come together and basically said we think these rules need to be in place. So we include those in ours, but we also have some Barclays custom rules added to the list. And this is part of our code generator template cookbook. We download our own Food Critic rules. And these are there ultimately to protect the platform, to make sure we're here to change management for certain things. So they include things like protecting the core operating system files. So you can't go into C Windows and start messing around with anything. Anything inside the par C Windows, it just says no. And the same for /etc. There are some exceptions in there. Obviously, certificates live under the /etc, etc. So we do have some exceptions, but on the whole, most stuff in those 2 directories have nothing to do with the application team, so they shouldn't be messing with it. We prevent service manipulation. We have just changed this. So originally we had a rule in there that would prevent anyone from creating, modifying, deleting, stopping, starting services. When you're doing your Chef training, you often find that's one of the key things that we do with Chef is maintain the service, make sure it's started. Some app teams come through and install the application, and by default, it doesn't start the service. You have to manually go and start it. You want to check that it is set to start after boot. You know, so on Windows, we set to automatic. On Unix, thing, we just set it to enabled. But originally we had that kind of locked down, so you couldn't do that. You had to whitelist. We've just changed that now, and we realised that you can't mess with our services, but your own services you can do what you want with. So we've kind of opened that up now, and we have a blacklist process on that rather than a whitelist. Prevent server reboots. A server reboot is a change managed task. Okay, so we understand, yes, if you install an application, you have to reboot the server straight afterwards sometimes, especially on Windows. But what we don't want is some rogue bit of code in Chef run, so that every time our Chef client runs, it could reboot that box every hour, for example. So we just have a look in there and we say, look, by default, we reject it. If you want to add it in, you can whitelist your cookbook to allow server reboots, but we expect to have some guards around the code that says that it'll only reboot if it installs some software. So if it checks the second time around, says, yeah, that package is installed, it will skip the server reboot and not even hit the code. So we look for things like that. We've got a load more in there as well. You can't create user accounts, local accounts. You can't create local groups. You can't really mess with permissions full stop because there's other processes that do that. And those processes are driven by a chef anyway. So it's kind of breaking compliance if you start messing around like that. And like I said, there is a whitelisting process. So you can whitelist certain things and certain rules. So we understand, like I say, you have to reboot a box after it's installed a package, but we will look for guards to be in place just to make sure that you don't break the chef run or cause the server to endlessly reboot. So that's Blueprinting. It's a very good tool for checking additional things that we want to make sure we maintain. And again, as it's part of the process of our part of our pipeline, you have to adhere to these rules, otherwise you can't even get your cookbook to the chef server. So it's a very good way of stopping it before it even gets anywhere near the chef server, not sort of retrospectively checking for it. We're being very proactive with it. So, Test Kitchen. So I mentioned before, we can't use Test Kitchen in Barclays the way that you would use it outside. So whenever you use Test Kitchen outside, you would just download Docker to your machine or Vagrant or maybe use AWS, Azure or something like that. And you just basically fire off Test Kitchen. You make sure you've got the right drivers and providers and gems, and off it goes and it works. It's great. But in Barclays, we can't do things like that on our desktops. We're not allowed to install Docker on desktops or Vagrant. We can't have people spinning up servers all over the place and all of a sudden they're appearing on our compliance reports. We have to make sure that we're in control of it, so we just don't allow it. So we had to come up with another solution to allow them to use Test Kitchen to at least check the cookbook executes and runs. So we come up with this Test Kitchen libvirt environment. So it basically allows our devs to test their code in an isolated and immutable environment. Okay, very, very similar to what you would do with Docker. So it's completely isolated, doesn't appear on any scans, it's in its own little DMZ effectively, and enables them to spin up VMs as they want and destroy them as they want. And they can do it as often and as frequently as they want to do. It's driven by Jenkins. So inside the cookbook, when you create it, inside our template cookbook, our code generator, we have a rake task that runs. And rake will then, we run a rake job or rake task. It will initiate a Jenkins pipeline that will read your kitchen.yaml file inside your cookbook and go off and build your whatever platforms you've specified, how many test suites you've got in there, that kind of stuff. So if you had one operating system, so say Red Hat 7, and you had 2 test suites, it builds you 2 VMs, 2 Red Hat 7 VMs, 1 for each test suite. And if you had 2 different versions of Red Hat, it will read it again and it will say, yep, you've got Red Hat 6, Red Hat 7, and you've got 2 test suites. I'll build you 1 version of Red Hat for each test suite, so that'll give us 4 VMs. Very, very similar to how Test Kitchen runs. It's pretty good. And it runs on a Red Hat KVM backend, so we've got 2 big beefy Red Hat KVM servers, and then we've got libvirt on top that does all the management of the VMs for us. So developers can do Windows or Linux, and it's a build very similar to our OS build. Some stuff doesn't work in it because it's an isolated environment, so we don't have AD in there. We don't have access to DFS. We only have limited antivirus on them, just whenever the last image was cut, because it's completely isolated. They can't get out at all. They can get out to the chef server and to some of our artifact repositories and to Git, but they can't get out to anything else. So it's nice and isolated. So the images they're running have got all the same security standards on them as Barclays maintain. We try and keep them as close to the actual builds they have in the environment so that they can catch any problems or conflicts they might have with settings, etc. And they have access to Yum and Nexus and things like that, so they can download packages from there. And these are short-lived VMs, so we have a process to try and maintain resource on these boxes, these KVM boxes. We have jobs that say that if a box has been sat there for longer than 2 hours since its build time, we just automatically destroy it. And that way you're not worried about running 10 boxes and leaving them running overnight and no one else can build anything. It keeps it nice and clean. So yeah, that's a way we've kind of got around Test Kitchen. And it does work very well. We are looking at expanding that out into AWS as well, because for the AWS specific cookbooks, such as the CloudWatch agents and stuff, you can't run those inside here because they don't have the components they need, obviously being linked to AWS. So we're looking to mirror this kind of solution for AWS as well, hopefully in the future. So we've got our cookbook to our chef server, okay, at a version. There's a crucial step we're missing in this process, and that's assigning that cookbook or something within it to a server, to a node, okay? So we give them a solution to upload, but what about the run list? So we need another process, unfortunately, more process. Self-service tool again, we do the same thing again, it's via a Git repo. We allow updates to node run lists and to the chef environment. So 2 key parts of the node object you can update via this process. We have to incorporate governance, controls, audit, and change management again, because we're financial institutions. We have to make sure that we tick all these boxes. And then we have some validation checks as well. You'll see the reason why we do that. And again, we don't want any input from the chef support team. We don't want them just constantly doing chef run list updates all the time for nodes, because it's just a time-consuming task. And with this process, we can automate it nice and easily, and it doesn't actually involve the chef team on any level, really. So for this, we developed a tool called the Run List Manager. So Run List Manager, basically, it's a Git repo. We have inside our Bitbucket Git repository, and we have a node.json file, so a node name, whatever the host name of the server is, .json, for every server in our environment, any server onboarded to the chef server. So as part of the onboarding process, it creates its node object file, and it looks very much like a role. When you look at it, it's got the name of the server, it's got the chef environment, and it has a run list. Okay, and this is how we control the run list of our nodes. What you do with this is you'll fork this repo into your own space in Bitbucket. You will then clone that down to your machine. You will then update the nodes you want to update. So update the run lists, or if you need to change the environment, you can change that as well. And then when you're done with that, you push that back up to your forked copy. Okay. We then create a pull request from the forked copy back to the master repo, and it sits there as a pending pull request. Now, as soon as that pull request starts, a build job kicks off, which will trigger another Jenkins job. Jenkins will run some audit tests first, so do some validation checks, because this is a JSON file, so check all your JSONs right, check all your syntax is there, you've not got some spaces, you're not missing your comma, or you've got an extra comma on the end, that kind of stuff. Once that passes, it triggers a ServiceNow change record. So again, it knows from the pull request all the node objects that were changed. So from that, it can pull a list of all the servers that were changed, puts those into the ServiceNow record. That will pull in all the right approval groups, because at this point, as soon as the run list changes on these boxes, that's when the chef cookbook change is going to affect it. So it's going to pull down this new run list, pull down the changed cookbooks, the updated versions, and it's going to execute. So we need the owners of those boxes to approve that change and be happy that when we're doing it, they're aware of it, and it's not in the middle of some massive batch job or some critical business event. So you've got to get it approved. Once it's approved, and within its change window, within about 10 minutes of the change window starting, the pull request will get merged, the run list manager master repo will update, and then we have a regular poll job that runs that then updates the chef server with those changes. Okay, so then chef server node objects get changed. At that point, the next time the nodes themselves check in, they'll download that updated run list, they'll pull down the change cookbook from the chef server, and then they'll execute it, and off they go. And hopefully, it all works great, and there's no mint. Okay, just a quick update on InSpec, because we are using InSpec. We use InSpec with Test Kitchen, so you can write your own InSpec tests as part of Test Kitchen, and just the same way you would do running it from Docker, and then Test Kitchen will execute the tests as soon as the box is up. But we're also using InSpec to do all our compliance checking now. So because we've got agents already running on the box, you might as well pull that data back in and use it for compliance, and that's what we're kind of driving towards now. So we've got the use for compliance reporting. We're using the CIS profiles, the standard profiles, which Chef have got a load of templates for already. And we are just adjusting them and adding some of our own stuff and taking some bits out we don't, not too bothered about. And then we're baselining that against all of our operating systems and builds. So we've got a number of different builds out there: RHEL 5, 6, 7, AIX 6 and 7. Still got Windows 2008 kicking about, 2012, 2016. And we're now diving into 2019 as well. I think Red Hat 8 is on its way out very, very soon as well. So we'll have profiles for each version of the operating systems and all those corresponding standards that go against them. We've got Chef Automate sitting in front of that. So that gives us all nice graphics and charts. So we can see the compliance stats of the boxes, see the ones that are going up red. And then hopefully we can start actioning and sending reports to the various owners of the boxes that your box is now non-compliant. Please book it in for maintenance or whatever they need to do. So the next phase will be to enforce it out. So we're going to push it out to all the areas, and it's going to be our key compliance reporting tool at least for the platform settings. And then hopefully what we can do then is get the application teams themselves to write their own profiles for their applications, and then they can then check their application compliance levels or where they're at as well. And then again, Automate can show them that all on the dashboard. So I battled through that. Quick recap. So quick intro to Barclays. I'll just give you a quick update on who we are. And the key driver there is that we are a technology company at heart, and we see technology as a key driver to our business, key enabler. The faster you are pushing new services and new products out, the more sort of value you give back to your customers. We talked about what problems we have as being such a large organization. So we're a humongous enterprise with a vast number of servers, vast number of developers and people. So that means there's a lot of change that's got to happen. We talked about then how we use Chef to get around that. Along with some of our automation, so our standard deployment pipeline. Also, we had a quick chat about the run list manager. And we'll have a quick plug. So we're always looking for new talent. We're always looking for new people. It's a brave new world out there in terms of IT. We're in the middle of a massive technology shift, and that's not just around skills, but it's also around process as well. So we're always on the lookout for new talent, always on the lookout for new people. So if you're interested, and if stuff in this presentation's kind of ignited your fires a little bit, then have a look on jobs.barclays.co.uk. And we've got positions all around the globe, UK. So yeah, we're always on the hunt for fresh new talent. So yeah, check that out and have a look. And I think that's me done. So I'm going to hand now over to Simon.
Thank you, Jay. Thanks for taking us through the story. It's a fantastic example of how a large traditional enterprise has managed to achieve automation at scale. So thank you very much. My name's Simon Fisher. I'm the Director of Technical Services, and to really confirm a lot of the things Jay has mentioned already and talk you through how Chef can help organizations achieve automation and faster speeds. McKinsey & Company said it best that many large traditional companies, a moment of reckoning has arrived. They must build a modern technology environment that can support multiple fast evolving solutions. And we've already heard that today. You know, the DORA research report says that the elite performers they observe achieve on-demand deployments and less than 1 hour time from commit to deploy. And it's all driven through automation. So the faster you go, the more successful you can be. And that's where we come in. Chef powers the coded enterprise. Our vision is that the most enduring and transformative companies use Chef to become fast, efficient, and innovative software-driven organizations. And we like to call these organizations a coded enterprise. As you've already heard today, code is at the heart of everything we do. You can do things faster with code. You collaborate around code, and you can build trust between teams. So this is the only way to achieve real, true scalability. And the collaboration through code is at the heart of everything we do. We have the Chef Enterprise Automation Stack. It's a system which allows you to express both your infrastructure, your security, compliance policies, as well as application lifecycle, all as code. As you've already heard this morning, pipelines are absolutely key to this. Code will give you the automation, and pipelines will give you the safety and the guardrails to make sure that automation is executable at scale within the confines of the enterprise. So pipelines are absolutely key to this, but as well as also reporting and understanding what is actually going on in your infrastructure, and the ability to make decisions, fix things which have gone wrong, and ultimately assess the benefits which you've achieved through automation. Now, you might be thinking, if we go faster, it increases risk and maybe makes things less efficient. But again, from the DORA State of DevOps report, we don't see that with organizations who strive to be and become these coded enterprises. You can achieve speed through automation, through defining everything as code and executing that. You become efficient because you can do things at scale, you can be repeatable, and it means things go wrong less. And if things go wrong, you save money, you save time, and there's less involvement from manual intervention. And finally, risk, the ability to audit on demand, and rather than spend endless weeks, months, and even years generating the right data to assess your risk profile. So you don't have to trade off. Everything can be in unison: speed, efficiency, and risk. So Jay's really done a great job of talking about this for me and demonstrating the benefits of the enterprise automation stack. But I'll just recap what Chef can provide. It eliminates friction. You don't have to worry about where applications are being deployed and how they're being deployed, because you defined it all as a coded enterprise. Pipelines are key. I mentioned already, you need a consistent way of deploying your applications through pre-production and into production for all of your applications. And what you definitely don't want to do these days is lock yourself in to the underlying infrastructure. The application is the unit of value, so make sure that that can be deployed in any environment. And that's what the enterprise automation stack can do. And then by making this all visible, you can collaborate across different parts of the organization and break down those silos which traditionally exist. And to recap, it's all as code. Code you can collaborate on with each other. You can test it, and you should test it, and you can execute it at scale. And that's how you truly can become a coded enterprise and achieve the benefits that brings. So again, I'd like to thank Jay and Barclays for telling their story this morning. It's a very impressive story of how a traditional enterprise has embraced code and automation. And I'd also like to thank everybody who's attended this webinar and taken the time out of their day, either watching live or watching the recording. So thank you very much.